Hey guys, this looks like a fun one. It says the circle inside of the equilateral triangle has an area of 16. What's the area of the circle inside of the rhombus? If you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. So I'm thinking all the rhombus is doing is just showing us that this is the same height as this. So let's mark the base with the dashed line and the top with the dashed line. So these two heights are the same. And more importantly, the height of the triangle is equal to the diameter of the circle. So let's focus on the height of the triangle. Let's call the radius of this circle x. That means that this radius would also be x. And if we extend this tangent line to the circle, this will be at right angles. And that's due to the fact that the radius of a circle is always at right angles to a tangent line at this point of tangency. And then from this vertex, let's bisect the angle down to the center of the circle. Since this is an equilateral triangle, each of these is 60 degrees, but this one is cut in half, so it's going to be 30 degrees. And inside of this triangle, all three angles have to add to 180, so that leaves 60 degrees for this angle. Now we're dealing with a 30, 60, 90 triangle. And 30, 60, 90 triangles always have this relationship. The hypotenuse is always double the shortest side. And let's rotate this. Let's highlight this side right here. This is the hypotenuse and the x is the shortest side. So the hypotenuse should be double the length of the shortest side, or in other words, 2x. And now we're done with the 30, 60, 90 notes. Let's take this x radius that we have here and copy it down here. So we can see the whole height of the triangle is x plus 2x or 3x. Let's take this 2x length and copy it up here. Now let's draw the diameter of the circle. This is going to be equal to this, and 2x plus x is 3x. So the diameter is equal to 3x. And that means this radius would be equal to half of that, or 3x over 2. Now I think we're pretty much done. Let's clean up this work, and we don't need any of this either. Now we have two circles, each with their own radius. For a circle, it's pi radius squared equals area. So for this one, we'll say pi x squared equals 16. And for the other circle, we'll say pi 3x over 2 squared equals question mark. And let's change it to this question mark. Let's simplify this. This exponent will go to the 3, the x, and the 2. And then we can bring down the pi and the question mark. 3 squared is equal to 9, and 2 squared is equal to 4. And now let's rearrange things a little. Up here, we found that pi x squared was equal to 16. So in the place of pi x squared, let's plug in 16. And 16 divided by 4 is 4. And 9 times 4 is 36. So we have 36 is equal to question mark. And this is the answer to our question. The area of the question mark circle is 36 units squared. This looks important. Let's put a box around it. How exciting.